Here we go. Okay, folks, so now we're looking for conditions for rhombuses, rectangles, and squares. Okay, so the first thing that we want to look at is another theorem, and this theorem has to do with the diagonals of a parallelogram, and it states that if the diagonals are perpendicular, then the figure is a rhombus. Okay, so you probably noticed, or you remember from 6.4, we talked about if it is a rhombus, then the diagonals are perpendicular. So what would this be? Would be the converse, right? So this one says if the diagonals are perpendicular, then what? It is a rhombus. Very good. Okay. So then the next one we have is if the diagonals are angle bisectors, then it's what? A rhombus. Okay. Again, notice that we're just using the converses, right? And then the next one, or the last theorem that we're going to use in this section, is if the diagonals are congruent, then the figure is a rectangle, right? So remember, the first theorem is if P then Q, and the converse is what? If Q then P. Okay, so let's look at what kind of practice problems we might see that would use this section, or the converse of these theorems. Okay, here's the first one. Can you conclude that the parallelogram is a rhombus, rectangle, or square, and why? Okay, so we're looking at this one right here, and what do we notice about this figure? What do we notice about this figure? That the diagonals are what? The diagonals are angle bisectors, right? So if the diagonals are angle bisectors, then what does that tell us? Then it is what? A rhombus. Okay. Now let's look at B. What do we notice about this one? Okay. The diagonals are perpendicular and what? And congruent, right? They're perpendicular and congruent. Well, perpendicular means that you have what? A rhombus, right? But congruent diagonals mean you have what? A rectangle. So what happens if we have something that's a rhombus and a rectangle? What is it? It is a square. Good. Okay. All right, now we have the got it. The got it reads that you have a parallelogram that has angle measures 20, 160, 20, and 160. Can you conclude that it's a rhombus, a rectangle, or a square? Okay, what can we conclude? What is it not? It's not a rectangle or what? Or a square. Therefore, it has to be what? Okay, remember the little 3 dots for therefore? It must be a rhombus. Okay? Yeah? Okay, let's look at the second one. This is this is problem 2, and we're going to use this property. Okay? Now we're told that ABCD is a rhombus. Okay? If it is a rhombus, what values of x would we have to have? Well, what do we know about angle ABD and angle DBC if this indeed is a rhombus? There would be equal. So I can say that angle ABD is going to be equal to angle what? DBC, because the diagonal BD must be an angle bisector, correct? So now I would just fill in the expressions for those. So the expression for ABD is 6x minus 2, and the expression for DBC is 4x plus 8. Okay, so if I just solve that algebraically, I'll have 2x, right, equals 10. Yeah, so x is going to equal what? 5. Okay, so in order for this to be a rhombus, x would have to equal what? 5. Okay, we'll look at the next one. This one reads that for what value of y would DEFG be a rectangle? Well, what do I know about the diagonals of a rectangle? What do I know about the diagonals of a rectangle? They're congruent. Yes, they're congruent, and they bisect each other. So therefore, 5y plus 3 must equal what? 7y minus 5. So that means that 2y is equal to what? 8. So y would equal what? 4. So in order for DEFG to be a rectangle, y must equal what? 4. Okay? Now let's look at a story problem. Builders use properties of diagonals to square up rectangular shapes like building frames and playing field boundaries. Suppose you are on a volunteer building team at the right. You are helping to lay out a rectangular patio for a youth center. How can you use the properties of diagonals to locate the four corners? Okay? How would you use the properties of the diagonals to locate the four corners? Okay, remember we want it to be a rectangle, right? So what do we know about the rectangle? How can we use the diagonals? How can we use them? The diagonals are what? What are they? They're congruent, and they also what? Yeah, and they also bisect each other, right? So how could we use that to make sure that we were squared up? Yeah, if we had them intersect at the midpoint, right? If we had them intersect at the midpoint and we kept them straight, wouldn't we hit the four corners? Yes, we would. Could you adapt this method slightly to stake off a square? How could we do it if we wanted it to be square? Well, yeah, I was going to say the diagonals would be congruent and they would be bisectors, but they would also be what? For a square, the diagonals would also be what? Perpendicular. So you'd also have 90-degree angles. Okay. All right, these are the practice problems that you have, not too many here on page 386, and it is numbers 8 through 14. Okay, let me know if you have any questions.